This is a video lesson for Module 5, Lesson 6. The Lesson 6 learning target is I can decompose fractions using area models to show equivalence. So we are going to be continuing to grow our understanding of equivalent fractions using area models, just like last lesson. But this time we're not going to be focusing solely on unit fractions. We're going to be looking at non-unit fractions as well. So let's go ahead and jump right into it with our first example. So for the first problem here, I'm going to be showing the equivalence of 3/4 in eighths. So my first step is going to be to represent 3/4 shaded in on my area model. So I'm going to go ahead, and I already have it partitioned into 4 equal parts, but I'm going to go ahead and shade in 3 of those parts. So you can see that I have represented 3/4 shaded in on the area model. So just like before, I'm going to be partitioning my area model horizontally in order to create my eighths. So I need to think about how many horizontal lines I'll need to draw in order to create eighths. And since I already have fourths, I know that eighths would be double the amount of sections. So I know I'm just going to need to cut this in 2 parts down the middle here. So I'm going to go ahead and draw my line across. So now I've created eighths, and I can tell because I have 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So I know that each of these sections in the shaded region are 1/8. So to show my equivalence of 3/4, I know that 3/4 is equal to 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Whew, that's a lot of eighths. I'm actually going to add some parentheses to my addition sentence here, though, to show the amounts of eighths that are combined together to equal just 1/4. So I know that 2/4 together is equal, 2/8 is equal to 1/4. So I'm going to put parentheses around groups of 2/8 to, in my head, kind of represent the equivalence to 2/8 to 1/4. So there's an addition sentence that is equal to 3/4. And so I know that 3/4 is equal to 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8, which is equal to 6/8. And of course I can also represent the equivalence with a multiplication sentence showing that 3/4 is equal to 6 copies of 1/8 or 6/8. But because I've also created these parentheses around these chunks of 1/8, another multiplication sentence that I could use to represent this equivalence is actually 3 times 2/8. So really 3 times 2/8 is the same as 6 times 1/8, which of course is the same as 6/8. So I have all these different ways that I can represent the equivalence of 3/4 to 6/8. So each of them is correct, but we have just lots of different options to show that equivalence visually and numerically. So let's go ahead and move on to our next example here. So in this example, we're going to be drawing a model to show the equivalence of 2/3 and 8/12. And I'm going to express the equivalence as the sum and product of unit fractions. So that means I'm going to need to write an addition sentence and a multiplication sentence to show this equivalence. So to start out, I'm going to look at my original fraction, 2/3, and I'm going to go ahead and shade in 2/3 of my area model here. I'm going to use yellow for this problem. So my next step is I'm going to be showing the equivalence to 8/12. So I know that I'm going to need to create 12ths in my area model. So that means I'm going to need to create 3 horizontal lines so that I can turn my 3 equal sections into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal sections. So each of my small little sections here is now equal to 1/12. So I can go ahead and write out the unit fractions for each of the shaded regions now. And remember, before we had this as 2/3. So I've labeled all the unit fractions of 1/12. And so I'm going to go ahead and now show the equivalence using a number sentence with addition. So I'm going to show that 2/3 is equal to, and I have 1, 2, 3, 4, 5, 6, 7, 8/12. Oops. Make sure I actually have an equals sign here. Equal to 1/12 plus 1/12 plus 1/12 plus 1/12. Whew. Plus 1/12 plus 1/12 plus 1/12. Gonna need a little bit more room here. I'm gonna zoom out just a little bit. Slide over. Plus 1/12. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 copies of 1/12. So just like in the previous problem, I can put some parentheses around groups of 1/12 that are equal to the unit fraction for my original fraction, which would be 1/3. So I know that 4 copies of 1/12 is equal to 1/3. So I can see that 2/3 is equal to all these 1/12 added together, which is equal to 8/12. And the problem asks me to show the equivalence as the product of unit fractions. So to write a multiplication sentence, I know that 2/3 is going to be equal to 8 copies of 1/12, which is the same as 8/12. And just like before, I can also show the equivalence with a separate multiplication sentence of 2 times 4/12, and that's utilizing the parentheses I had added to my addition sentence from before. So that all of this shows, all these different ways show that 2/3 is equal to 8/12. So let's take a look at one last problem here. And this problem's kind of open-ended, and we're just going to be finding equivalent fractions for 2/5. So there's all sorts of equivalent fractions for 2/5. So I'm going to show you just a couple ways that we can do this. So first I'm going to represent 2/5 in my area model by shading in 2 of the 5 equal parts that I have. So I have created 2/5 of the area model. Now to find one equivalent fraction, the simplest way and the simplest thing I can do is I'm just going to cut my area model in half lengthwise here. And now I've created tenths. So each of my unit fraction is now 1/10. So if I look at all four, at the number of sections that are shaded in, I have 4. So I know that 2/5 is equal to 4 copies of 1/10. And so I know that, which is equal to, of course, 4/10, or that 2/5 is equal to 4 copies of 1/10, which is equal to 4/10. So that's one equivalent fraction. 4/10, that's one equivalent fraction to 2/5. But if I wanted to go a little bit further and find more equivalent fractions, I can just keep on splitting up my area model into different size parts. So I'm going to go ahead and cut each half in half. And so now I've created, let's see what I got here, 1, 2, 3, 4, 5, and there's 4 rows. So I've created 20ths. So I've cut the size in half, and so now I have each unit fraction is 1/20th. And if you look, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 small sections that are now shaded in. So I know that 2/5 is equal to, this is going to be a big addition sentence here, 1/20th plus 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 1/20th. Whew, it's a lot of 20ths. So that's all, of course, equal to 8/20ths. Or the simpler way would be actually with a multiplication sentence to show that 2/5 is equal to 8 copies of 1/20th, which is 8/20ths. So of course now, as you can probably tell, if we were to continue cutting each of our sections in half, we could create more equivalent fractions. So if I wanted to, I could cut them in half like this, which would create 40ths. And there's all sorts of different ways that I can create equivalent fractions for 2/5. I can go on forever and just keep creating equivalent fractions. But for today, I'm just going to go ahead and stop with 2 different ways to do equivalent fractions. So hopefully this is helping your understanding of equivalence and finding equivalent fractions. And now you should be able to tackle all the problems in the Lesson 6 problem set. But of course, if you get stuck, you can come back, rewatch the video, or any parts that might help you with some of the problems in that problem set. So good luck with your Lesson 6 problem set, and thanks for watching.